So in this video, let's proving the famous quantum mechanics, also a very simple proof called no cloning theorem. So the cloning means that you duplicate something, right? So the idea is that if somebody give you a simple quantum, somebody give you a state psi, and you hope that there is a operator u such that which is unitary, which somebody give you a psi tensor at 0. This is called ancilla, but you don't care. You act on u, and then it will become psi tensor psi. Okay. So the answer is that no cloning, right? So answer is no such u exist. So usually such u cannot be unitary. Such u cannot be unitary, and then we will prove more stronger is that such u cannot be linear. So u is not linear operators, hence it cannot be a unitary operators. Okay, so let's just quickly see the proof. Okay, so proof that say u exist. Right, so you is a smart guy, which if somebody give you alpha 0, somebody will give it alpha 0, then you will produce alpha 0 tensor alpha 0. So it's just alpha squared 0 0. And beta 1 exists, so you act on beta 1 will give you beta squared 1 1. But how about you alpha 1 alpha 0 plus beta 1, right? Then you will become alpha 0 plus beta 1. Tensor alpha 0 plus beta 1. So a very simple result will be alpha squared 0 0, alpha beta 0 1, beta alpha 1 0, and the beta squared 1 1, right? And this guy is not the same as alpha 0 plus u beta 1 because there will be cross term, right? So this is not the same. So hence u is not linear. So u is not what? Unitary. Right, so u cannot exist as quantum operation. Because we are assuming that the idea in the quantum computing is that we are assuming that all the operators act on state must be unitary operators. Okay, but there is a stupid remark. Remark is that how about C naught? Right, so some guy will say that C naught is C naught is somehow like C because C naught act on 0 0 is 0 0, and the C naught right I mean C naught echo on 1 0 be 1 1 or something. So it's somehow like people would say, oh, maybe C naught somehow cloning 0 and 1, right? So you see C naught clones 0 and 1. Suppose I view 1 is the ancilla, right? So if somebody give you 0, then become 0 0. If somebody give you 1, it become 1 1. So somehow C naught clones 0 and 1, right? But so this may looks like violate the no cloning theorem, but the result is that the C naught only clone. So the fact that C naught only clones 0 and 1, not arbitrary this guy, right? So C naught will not violate the no cloning theorem. Okay, so this is just simple remark, and this theorem is so simple. Okay, I will see you guys in the next video. Be sure to subscribe to my channel. Thank you.